Welcome to week 7. We're going to jump right in. Okay, so today we're going to introduce factoring. Okay, and then we're going to review some previous concepts, and we're going to go through some piecewise function problems. And I've had some feedback that we're still kind of unclear on that. We're going to slow down on piecewise function problems and hopefully really nail those down. Okay. So let's talk about factoring. So first, we're going to go to a little diagram, beautiful diagram that I've drawn. You could see that I could also be like an arts major with my beautiful work. Okay, you're going to see factoring problems. And this is the way I want your brain to think. Good morning. Okay, this is the way I want your brain to think. I want you to think, step number 1, do I have 2 terms, 3 terms, or 4 terms? Okay, there could be more than 4, but anyway, okay, if we have 2 terms, step number 1 is try to factor out a GCF. Okay, always factor out a GCF if you can. Do they have a common factor? Okay, now if it's a 2-term problem, it is either GCF, so you factored out the GCF and you're done. There's nothing more to do. Or if it's a 2-term problem, it could also be difference of 2 squares, affectionately referred to as dots. Difference of 2 squares. Those are your options for 2-term factoring problems. Okay. Now, what if the factoring problem has 3 terms? Okay. Step 1, we are always going to look for a GCF. Okay. Always look for a GCF. Now, after we factor out the GCF, we look at the problem. So for example, x squared plus 7x plus 12, okay, A equals 1, B equals 7, C equals 12. Now, you're going to see this, and if you Google factoring video A equals 1, we just call this group of factoring problems that do not have a coefficient in front of the x squared. Technically, the coefficient in front of the x squared is 1. Okay, now I'm the only one that calls this. These are just easy diamond problems. And we started talking about these the first unit, the first month. Okay, then you're going to have a group of problems and they're much harder. All of a sudden, a coefficient shows up in front of the x squared term. I know you're probably thinking, clear your voice, clear your voice. Anyway, okay, notice A does not equal 1 because we know A is the coefficient in front of the x squared. So we call these difficult, and we do rainbow, diamond, box. Okay, so that is category 2, 3-term factoring problems. Does that x squared term have a coefficient in front? If not, then we rejoice. Yay. And you want to Monty Python fan. Anyway, and there was rejoicing. Yay. Okay, if we have a coefficient, oh, sorry, typo, that's an X. We don't have two variables going on. If we have a coefficient in front of the x squared term, oh, woe is me. It is a difficult problem. We have to do a rainbow diamond and box. Okay, so what if it has 4 terms? Step 1, check for a GCF. Okay, if it has 4 terms, check for a GCF. Now, 4 terms, we're going to try a box. The category of this box, I'm the only one that calls it box. If you're looking for videos, this is factor by grouping. That's what the rest of the world calls it. Now, I'm going to tell you too, this is where, okay, now let's just be honest. We know you guys look at PhotoMath, right? But you're not just writing down what PhotoMath says without any thinking. This is where PhotoMath differs from me. Okay, PhotoMath is going to give you the old-fashioned way to do it. But if I say demonstrate the diamond and the box, you will not get that from PhotoMath. Okay, PhotoMath can be a good reference, just like looking. Yes, this is week 7. I'm going to get to that. PhotoMath is okay to look at as a reference. Okay, but PhotoMath will lead you astray and teach you the old-fashioned way to do it. And there's a possibility you're writing down all this stuff and you don't even, like, it doesn't even make sense. So watch out for PhotoMath when it comes to factoring. I recommend don't even look at it. Okay, it'll just make it more difficult. Okay, so we have 2 terms, 3 terms, and 4 terms. Now, back to week 7. Okay, I'm going to pause in case you want to take a picture of this, but this will also be in the video if you want to see it. Okay, week 7. There are actually 5 types of factoring. I don't know why I just always say 4. Number 1, GCF. Okay, but GCF overlaps the other ones because we should look for a GCF before we go on to the others. Number 2, difference of 2 squares, right? Difference of 2 squares. Okay, we'll talk about that. Now, these are if it has 2 terms. Okay, that's not true. GCF could be 2 terms, 3 terms, 4 terms, 5 terms. But if it has 2 terms, it can only be GCF or difference of 2 squares or not factorable. Okay. Then if it has 3 terms, it could be easy diamond, or difficult, which is rainbow, diamond, box. Okay, now if it has 4 terms, we go straight to the box, which is perfect. It has 4 terms. My box has 4 spots. Perfect fit, match made in heaven. Okay, so you are going to do better if you see a factoring problem and you first categorize it. 2 terms, 3 terms, or 4 terms. Which type of factoring does this fall under? Number 2, factor completely. Step 1, is there a greatest common factor that all the terms have? Do they all have an X? Nope. Do they all have A 5? No, there is no GCF, but we checked. Okay, 4 terms, not difference of 2 squares, not easy diamond, not rainbow diamond box. I'm going to go straight to the box. Okay, I happen to have 4 terms. Typo. Okay, make sure that's correct because I messed it up. Okay, so I have 4 terms. I have 4 spots in my box. So step 1 is the box. Step 2, look for row GCF. Okay, so we're going to look for row GCFs. So we're going to look at these 2 terms. The GCF of the top row. Their coefficient does not have anything in common. But we can see that the biggest variable term that they both have ends up being the smallest of the row, right? Because it has to be in common. I can't do x cubed because not everything has x cubed. So that is the row GCF. Okay, so now I'm going to multiply. Now we've been practicing with the box. Yeah. So x squared times something gives me 4x cubed. Yeah. X squared times something equals 4x cubed. Can you see that I need a 4 and I need one more x? So that goes here. Okay. How are we doing so far? I took my 4 terms, I put them into the box. I found the row GCF, and now I'm going to complete the outsides. Okay, how about this one right here? X squared times what is 5x squared? What's missing? Yeah, Zoomers, can you tell me what's missing? Right there on the top, outside, top right. All right, so can we see that a 5 is missing there? Okay, how about this one? Something times 4x equals 4x. Yeah, something. See how the outside times outside gives me the inside of the box? Okay, so what's going to go right here, Zoomers? 4x times 1. Yeah, equals 4x. And now let's check it. This one times this one should give me, yeah, do we see how it's bottom left times top right? Yeah, you see how this is working? 1 times 5 equals 5. Yay. See how that checks it? We get a happy face. So 4x cubed plus 5x squared plus 4x plus 5 factors into final answer x squared plus 1, 4x plus 5. Okay, box, row GCFs, complete the outsides. Now, this may look a little overwhelming, but with practice, it's just like a mechanics. Okay, we're just going to go through the mechanics of this. Number 3. First category. Okay, look at your 5 categories on the top of the page. What category was this? Let's see, I have 3 terms. Now, so 3 terms, it's going to be one of these 2. So we need to decide 3 terms easy or 3 terms difficult. Okay, so remember our little chat at the beginning with all those bubbles? This is 3 terms. Is this 3 terms easy or 3 terms difficult? How do we know? Uh-oh, we have a coefficient in front of the m squared. Yeah, if we have a coefficient in front of the m squared, then it's 3 terms difficult. So we're going to do rainbow, diamond, box. Okay, rainbow. Bye. Thanks. Okay, so we make a rainbow with the first term and the last term. Not completely Roy G. Biv accurate. Okay, so we make a rainbow with the first term and the last term. And we multiply 5 times -12 is 60. Oh, is that correct? Or did I leave something out? 5 times -12 is 60? Ah, -60. Okay, thank you. Okay, that is the rainbow step. You don't have to use all those colors. Now I make a diamond with -60 and -4. Rainbow diamond box. There's a lot of different ways to factor this. In fact, one of them in one of your videos involves this fraction method. I personally love rainbow diamond box. I never use the fraction method. In fact, if you came in and said, hey, can you show me how to do the fraction method? I'd have to look it up because I don't like it. I don't personally like fractions, but there's a video, and like maybe 1% of my students, like 1 out of 100, actually like this better, which I can't imagine. But I use the rainbow diamond box method. Lots of different methods on factoring this. I want you to demonstrate that you understand the rainbow diamond box method. Okay. Photomath will not show you the diamond, guaranteed. Okay. Okay. So we're going to go to the chart of factors. I need 2 numbers that multiply to get -60 and add to get -4. And I'm preaching to the crowd because you're showing up here, I know you actually want to learn how to do it and not just get the answer. Okay, I need 2 numbers that multiply to get -60 and add to get -4. I go to the chart of factors in the 60 box. So how can I get 2 numbers that multiply to get -60 and add to get -4? Anyone see it? All right, ding, 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 right here. So when I add, I want to get a -4, right? -10 and +6. Do you see how that gives me -60 when I multiply, -4 when I add? So -10, +6. Okay, now I'm going to make a box, just like the one to the left. So I put 5m squared here negative 12 here. I got negative 10 and positive 6. Now, first box, last box. See that negative 4m? I need to split it between the two boxes. How am I going to split it? That I use the diamond to show how I'm going to split my middle term. So I put m's here and I put negative 10m and positive 6m. Now, if you were here in person, this is where I would say, turn to your neighbor and make sure they're not lost, but you guys can't do that. So how are we doing? Okay, this is a difficult problem. Okay, good. Awesome. Thank you for the feedback. This is a difficult problem. We have to do the rainbow. Then we do the diamond. The diamond tells us how to split the box, how to split the middle term and put it into the box. Okay. Now, Zoomers. Oh, good. Yay. Okay. I'm going super slow, but with practice, if you do a bunch of them, you're like, bam, 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 done. Okay. It just feels slow and painful going through it slow like this. Now, can anyone, I'm going to change to my highlighter. Can anyone guess what is the next step? Look at the one to the left. What is the next step? I figured out, ding, 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 outsides. Okay. I need the GCF of the top row. Okay. So I want, rainbow diamond box, GCF of top row. So the greatest common factor. I notice that a 5 will go into both of those. Notice it's the smallest thing they have in common. And an M, right? The smallest thing they have in common. You with me? Next step, right there. 5m times what, right? Notice this is the answer. 5m times what gives me 5m squared? Anyone have a guess? 5m. Ooh, more than that, but thank you. 5m times what gives me 5m squared? So 1 is the coefficient. Yes, but what else is missing? Do I have enough m's? Nah, I need another m. Okay, so we'll put 1m, knowing that a 1 could be invisible. Okay, so 5m times 1m is 5m squared. 5m times, what well, I didn't mean that one. I meant like here. 5m times what is negative 10m? I have enough m's. All I need is, Zoomers, ding, 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 negative 2. Yeah, better. Okay, how about this one? You could either look at the GCF of the bottom row or just go 1m times what gives me my 6m? What am I missing here? Looks like I have enough m's. Looks like I need, ding, 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 6. Now, I'm really hoping that this number times this number will give me this number. Yeah, ding, ding, ding. Okay, 6 times negative 2 is negative 12. Happy face, it worked. So factors into 5m plus 6, m minus 2. So rainbow, diamond, box, GCF of the top row, complete the outsides. That's a 6. We see that, right? Rainbow, diamond, box, GCF of the top row, outsides. Okay. The outside, yes, the outside is the answer. Okay. The outsides give you the answer. All right. Okay, awesome. With practice, if you kind of get it now, with practice, you're going to get really good at this. Okay. Step 1, I have 3 terms. Step 2, the coefficient of the squared term. Okay. Yeah. Okay. But this is why it's so important. These Zoom sessions are so important. Okay. In fact, I have found that some students are actually more interactive because they type in, and some students are like, I have students that are totally interacting with me, and then they come do the Zoom, do the review session in person, and then they are too quiet. Anyway. Okay. 3 terms, right? The coefficient of the leading term is not 1. So 3 terms, A does not equal 1. Yeah, now that's not you can tell that's not something I use kind of like quirky names, but because the whole world calls it A not equal to 1, that's what we're going to call it. So this is difficult. We're going to do rainbow, diamond, box. Okay, 3 terms, A not equal to 1, rainbow, diamond, box. Are you with me? Step 1, rainbow. What do I do with the 3 and the 20? Ding, 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 multiply. Okay, I did my rainbow and I multiplied. What's my next step? Can you see it right here? Can you see what the next step is? Yeah, we're going to make a diamond. So I want 2 numbers that multiply to get positive 60 and add to get negative 17. Okay, I'm going to check the chart of factors. Positive 60. Oh, it's 60 again. It was 60 the last time. Okay, positive 60 and negative 17. Positive 60 and negative 17. Can you see how the chart of factors is your new best friend? And if you're new to my class, when you come in to take your in-person exam, you will have the chart of factors. I've got a gazillion of them photocopied here. Okay, so you need to have the chart of factors. If you don't have one, if you're new, look in module, it's either in module 1 or the resources module, and you can print it out or stop by because I have them here. Okay, I need 2 numbers that multiply. Oh, careful, careful. And add to get negative 17. Can you see that this is going to have to be a negative times a negative? Because a negative times a negative is going to be positive. And there's 2 that look like they could possibly work, but only one pair gives me positive on top and negative on the bottom. Yeah, see how misleading? See how both of those would give me the 17? Yeah. Okay. So negative 5 and negative 12. When you multiply, you get a positive 60. When you add, same sign sum, you get negative 17. Yeah, we good? Negative 5 and negative 12. Rainbow, diamond. What's my next step? Rainbow, diamond, box. All right. 3m squared goes here. 20 goes here. Oh no, what should I do? I have 4 spots in my box and I only have 3 terms. That negative 17 is going to have to be split into 2 terms. Yeah, I'm not going to put negative 17. What am I going to put in the 2 places in the box? Uh-oh. Phone's ringing. Sorry, not during Zoom. Okay, so negative 17 gets replaced with negative 5m and negative 12m. Yeah, you with me? That's why you have to do the rainbow. Okay. I mean, that's why we have to do the rainbow and the diamond, because that it reminds me of Aladdin, diamond in the rough. Sorry, random thoughts. Okay, focus. Negative 5m and negative 12m. Everyone see? Yeah, Zoomers, yes or no? Do we see where I got the spot everything into the box? Yeah, we're good? Okay, so rainbow, diamond, box. My next step is GCF of the top row. Notice I could have switched those two. Yeah, and you would still get the same answer. They would just be switched. Okay. GCF of the top row. Oh, they don't have much in common. The only thing they have in common is what? Can someone help me out? Not much. M. Thank you. I'm just going to put M. I could put 1M. Yeah. But the 1 sometimes becomes invisible. Okay. So M times what is 3M squared? M times what is 3M squared? I could see that I need a 3 and an M. Does everyone see where I got the 3 and the M? And do you see that I'm multiplying edge times edge to get the box? That's why we've been practicing a boatload of exponents, okay, to get you guys ready for that spot, for this moment in time. Okay, I gotta erase this. Okay, M times what is negative 5M? Yeah, Zoomers? Negative 5. Yeah, M times negative 5 is negative 5M. Okay, Zoomers, what goes right there? 3M times what is negative 12M? 3M times, now I do not, can you see that I do not need any more M's? The only thing I need is 4. Is 4 correct? Thank you, negative 4. Okay, now cross our fingers, cross our toes. I need this and this to give me this. Negative 4 times negative 5 is positive 20. Yes. Got it. Now, if you made a mistake somewhere, it's not going to equal, and you're going to go back and you're going to find your mistake. Okay, the outside edges. So complete the outsides. The outside edges give us our answer, m minus 4 and 3m minus 5. Okay, if you had switched the negative 12m and the negative 5m, you would get 3m minus 5 and m minus 4. Both of them are correct because we know that multiplication is commutative. Yeah, meaning we can switch the order. Hopefully better. Hopefully it's getting better. Next. Okay, so I started with the most difficult ones. This one we have been practicing. Stop. What are you doing? Okay, you're not seeing that, so I guess we're okay. If I click that box, I think my Zoom will die. So I'm not going to click that box. Okay. Okay. Notice I have 3 terms. And A, yeah, do we know what A is? What is A for this problem? A is 1. What category is this? Easy diamond. Now, I'm not going to do the box. You can do the box. If you're like, no, I'm doing the box because otherwise I mess it up. You can do the box. But if A equals 1, it is a category easy diamond. You don't have to do the box. Yeah, it's not like 5n, just n squared. Okay, if I were to do a diamond, 1 times 3 is 3. Can you see that my box, my diamond still looks like that? Yeah, because I'm really multiplying 1 times 3. So I need 2 numbers that multiply to get 3 and add to get 4. That would be 3 and 1. You with me? Okay. So easy diamond. So we do the diamond and we go straight to the answer because A equals 1. Yeah. So done with these. The answer is n plus 3, n plus 1. Okay. This problem, this type of problem, 3 terms, A equal 1, easy diamond, could be your favorite math problem of the entire year. It's actually really cool. If we were in class and we met 5 days a week, we would practice a bunch of these and you'd be like, bam, 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 got these. But we only meet once a week, so we're moving on. Okay, if you have questions, stick around at the end and we can talk. I see 2 terms. No. Yes, okay. I see 2 terms. So number 6, I see 2 terms. Now, we're going to talk about difference of 2 squares in a minute. 2 terms, this is GCF. Now, for some reason, historically, students have a hard time with this problem, and I cannot figure out why. Okay, now you should see, when you see A squared in your brain, you should see that. And 7a is that. Those are A's. Looks kind of funny, but okay. What is the greatest common factor of those 2 terms? A, right? Do you see that both terms have an A? So if you know how to distribute, you know how to GCF factor because it goes the opposite way. A comes out. Now think this is the opposite of distributing. The A came out and that left A plus 7. Okay, it's super important that you understand the distribution property so that you can see that that's what that is. I would put that on a flashcard because for some reason everyone forgets. Okay, easy one-step problem. That's it. Okay, moving on. Now I have two terms. Do they have a GCF? Nope, we checked and they don't. Nothing in common. They are separated by subtraction. Now, something is special about the numbers 4 and 9. 4 and 9 are special, and they are in the group of numbers we call what? One squared is 1. Oh, not prime. It starts with a P, but it's not prime. 2 squared is 4. 3 squared is 9. It is the group of numbers, but thank you for participating. Perfect squares. Okay, now you're not going to have to do this. These you're going to get super fast and you're just going to go, you're just going to get the answer. But let's pretend we're putting 0n in the middle. Okay. Let's make a rainbow. -36. This is the long way, but it's going to show you that it works. Doing this the long way, I need two numbers that multiply to get -36 and add to get 0. Yeah? Two numbers that multiply to get -36 and add to get 0. Do we see that that's 6 and -6? Do you see where the 0 came from? I had no middle term. That means it is a 0. Yeah, are you with me on the fact that that really is a 0 in the middle? And the only way to get a 0 on the bottom is if the numbers match with opposite signs. Okay. Now, when I show you, when we get to the end, you're going to be like, oh, that's so long. Do I have to do that? I'm going to show you a shortcut. Okay, everyone with me. So I'm going to put 6n and -6n. Okay, are you with me? Okay, GCF of the top row is 2n. 2n times 2n is 2n squared. 2n times 3 is 6n. You with me? 2n times -3 is -6n. and -3 times +3 is 3. It works. Okay. So I started with 4n squared minus 9. And I did rainbow diamond box, and I got 2n. I'm going to switch the order. +3 and 2n minus 3. Now, this is called difference, right? Difference means like sum is add, difference is subtract of 2 squares. Does everybody see where the name comes from? Difference of 2 squares. Okay, now of all of them, you're going to get super quick at this. Does everybody see that I don't have to do rainbow diamond box because we see a shortcut? This is category dots, difference of 2 squares. Yeah. So here's the shortcut. Let's not do the box. 4n squared minus 9. This is a perfect square. You with me? Do we like shortcuts? Yeah, we like shortcuts. But this proves that it works. And then you go 2n plus 3 and 2n minus 3. Difference of 2 squares. Yeah. So the difference of 2 squares, it can be done rainbow diamond box. But why do rainbow diamond box when you can use the dots shortcut? Okay. So dots shortcut. 3x plus 2, 3x minus 2. Yeah? Dots shortcut. What category is it? Dots. 9 and 4. Is 25 a perfect square? Yes. I did that wrong. Very important that that 2 goes on the outside, right? Okay, what's the answer for number 9? Five n plus 1, 5n minus 1. Okay, so that was factoring. I just spent 40 minutes on factoring. We went really slow over those 9 problems. Okay, if that was too fast for those last 2, we'll come back to it. Number 10. If you are new to us, you need to know how to find the explicit formula. It's in weeks 1 through 4. Do not do. We're doing enough today. Number 10, 11, 12. All of these do not do. Okay. If you are new to the class, you will, okay, number 13 will need to come back to later. Well, not this one, but that topic. They will be on the final exam. They were on the week 5 exam, but we're not doing them right now. We're moving on. Number 14. Solve the system of equations using elimination. Okay, so elimination is also called add down. We talked about these last week. So pick a variable to cancel. Var, pick a variable to cancel. We're going to make it match, but it needs to have opposite side signs. So that when we add down, it will cancel one of the variables. Okay. Can you see that one of these is going to be much easier? One of these variables is going to involve less arithmetic than the other. Yeah. Can you see that for this problem, the y is the easiest to cancel? Everyone agree? If I want my y's to cancel, since I have a positive 3, the coefficient on the top one must be a -3. So we are going to distribute -3 to both sides. Yeah, can you see that my goal is to cancel those y's? Okay, so let's distribute. -3 times -3 is positive 9x minus 3y. Don't forget the other side, positive 45. And bring the other one down. Okay, my whole goal in using the elimination method is to pick a variable to cancel, make the coefficients of that variable match but opposite signs, add down to cancel. So let's check. Is this set? When I add down, will my y's cancel? Yes. 9x minus 5x is 4x. -3y and positive 3y cancel. 45 minus 29 is 16. So I went from 2 variables and 2 unknowns to a simple little equation with 1 variable, 1 unknown. Pick a variable to cancel. Make the coefficients match with opposite sides. Add down and solve. Divide by 4. X is equal to 4. So my ordered pair is 4, comma, I don't know. Okay. Plug in 4 other variable. Okay. Now I get to pick either equation number 1 or equation number 2. I'm picking 1. -3 times the x that I just got plus y equals -15. You with me? So we started these last week. Hopefully this looks a little bit better than the first time you saw them. Okay, -3 times 4 is -12 plus y equals -15. Solve the equation, add 12 to both sides. y is equal to -3. The point where those two lines intersect is 4, -3. Okay. Now, that was the elimination method. This is the substitution method. We are reviewing. We started this last week, but I think we need to do a few more examples. Okay. Now, notice there's two categories. This one, we have y equals, and 16, we have standard form. One is in standard, one is in y equals. They have two different beginnings, but they are both substitution. Okay, we have two equations solved for y, two equations in y equals method. Okay, so step number 1, hook them together. Yeah, we're taking out that y and we're putting 3x minus 5 in its place. Okay, hook them together, solve. I'm going to add 2x to both sides. 5x minus 5. Uh-oh. Everything's gone on the other side. Is equal to 0. Okay, add 5 to both sides. 5x is equal to 5. Divide by 5. X equals 1. Hook them together, solve, plug in. Let's plug it into the top one. Y equals 3 times 1 minus 5. Y equals 3 minus 5. Y equals -2. Okay, so we're going a little bit faster because we did these last week. The ordered pair where these two lines intersect, 1, -2. Notice if I plug 1 into the top or the bottom, they would both give me y equals -2. Okay, so I'm using the substitution method, and both equations are in y equals form. Now, I have one equation in standard form, the second equation in y equals form. So we're going to plug this one in to the standard form one. So 6x minus y is equal to 13. So we're going to take out the y, put in parentheses. So I took out the y. Notice y is gone. What am I putting in its place? I am putting, what is y equal to? I'm replacing y with 8x minus 19. Okay, so we're going to plug what? We're going to plug 8x minus 19 into the standard form equation. Next step, distribute. Notice I put parentheses, otherwise you're going to get a wrong answer. 6x minus 8x, that negative goes in and it becomes positive 19. Okay, don't forget those parentheses. Okay, let's combine like terms. Negative 2x plus 19 equals 13. Subtract 19. Negative 2x is equal to negative 6. Divide by negative 2, x equals 3. Next step, plug in. Now, do we see that that one is a lot easier to plug in and solve for y? Y is equal to 8 times the value I got for x minus 19. Which is 24 minus 19. X equals 3, y equals 5. These two lines intersect at the ordered pair 3, 5. So, new material factoring. Last week, so we reviewed solving by elimination and the two types of substitution. Number 17. Okay, now we don't practice this a lot, but I'm going to tell you right now, number 17 will show up on the week 9 exam. And you're going to need to remember where to start. Okay. Notice I have a quadratic. In order to solve a quadratic with 3 terms, you have to go factor, split, and solve. So I need to factor this. 3 terms. A is equal to 1. So we're going to do diamond. So I need two numbers that multiply to get positive 24 and add to get negative 11. Negative 8 and negative 3. So we factor into B minus 8 and B minus 3. Okay, so I know that this times this equals 0. Now it's time to split. So I know that either B minus 8 equals 0 or B minus 3 equals 0. This is called the zero product property. The only way to multiply two numbers together, one or both must be 0. So now we solve. Add 8, B is equal to 8. Add 3, or B is 3, and or. Okay, we're out of time, so we're going to say do not do for number 18. But when you see this, and it's going to show up on the test, factor, split, solve. Okay, so here's the scoop. Number 19, we're going to cross off, but I'm going to tell you it's on the week 9 exam as an extra credit problem. It's not that bad. It involves substitution. I'm going to do it at the end. We're not doing that one. I'm going to do this at the end. If you want to learn it so that on the week 9 exam, you can do it and get the extra credit, then it's not that bad. Okay. It's just a little overwhelming because we're learning a lot of stuff. We're going to come back and we're going to do number 19. You do not have to do it on the review session packet. Okay. It's only stick around if you want to see it and see if you want to learn how to do it for the extra credit problem on the exam. Okay. 21 and 22 on your own, and 23 and 24 on your own. Let's talk about piecewise functions. So we have 3, this is broken down into 3 pieces. So step number 1, change this to y equals. I have y equals -2. Yeah, see where I got that? That's one piece. Y equals 0. That's the other piece. Y equals -x. There's my third piece. Now, none of these have any exponents, so I can see that these are linear. I'm going to make a little table. A little 2-point table, because I only need 2 points to determine a line. Okay. let's look at part 1. One of my x values needs to be -4. And the other needs to be a number less than -4. Yeah. So one of them has to be -4 and the other a number less than -4. So I'm going to go -5. Okay. Now, what does this equation look like? Y equals -2. Notice there's no x, right? So we're like, oh, wait, when there's no x, I think of the word, yeah, a y equals is horizontal. So y equals 2. When x is -4, y is -2. I said equals 2, -2. When y equals -5, when x is -5, y equals -2. There is no variable for this part 1 of the equation. Okay. No matter what x is, y is -2. So -4, -2. It's a trick. It's right there. -5, -2. Okay, let's look at that top equation. This is an arrow. To the left. Now, there's one more thing I have to fix. See how this is not equal to? I need to put an open circle there. Okay. Next part. Part 2. Y equals 0. I'm going to use x is -4 and x is +1. Notice this is horizontal. When x is -4, y is 0. When x is +1, y is 0. There is no x value for that. So when x is -4, y is 0. When x is 1, y is 0. Connect them. So at the -4, we have a filled in circle. At the +1, we have an open circle. Okay, third part. I'm going to use x equals 1 as my first number. And my second x number needs to be a number greater than 1. So I'm going to go 2. Sometimes I go much greater because my lines end up being really small. Okay, y equals negative x. Plug 1 in and I get y is negative 1. Plug 2 in and I get y is negative 2. 1, negative 1. 2, negative 2. This is an arrow to the right with a filled in circle here. Okay, I went 5 minutes over your time. You do not have to do number 26 unless you feel like you need to see one more example for piecewise function. I will stay and do it. Okay, so I try to be done by 11:45. We went a little bit over, but I felt like I needed to go really slow on the factoring. That is it for today. Okay, if you want to see the extra credit problem, it's not extra credit for the packet. It will show up on your in-person exam. Now I'm going to tell you, if you do the exam online, there's no extra credit. Okay. If you are new, then sorry if this feels really overwhelming. Hopefully some of the stuff you saw in your previous class. Yes, yes, you turn this in the modules. You will see under Tuesday, it's called RSP. That's where you turn it in. Okay. If you think you want to try the extra credit on the week 5 in-person exam, we can do number, whatever it was. Where is it? Number 19. Okay. If you decide later you want to see it, then I believe last year's video I did it. And if not, 2 years ago, I did it. Okay. Does anyone want to go ahead and see substitution for an equation that has an exponent in it and maybe possibly do it on the in-person week 9 exam? Or do you have any questions? Anything we need to see again? More explaining? 21, 22, 23, 24 is on your own. Okay. Can you do those? Any questions? I realize that's a lot of math to cram into your brain. Keep in mind, if this was traditional school, this lecture would have been split into 5 different days. The good thing is you don't have to come meet with me 5 times. The bad news is it's kind of a lot of information for an hour and 15 minutes. Okay, questions, requests? Questions, requests? Yeah? Anyone want to see number 19? I'll just tell you, solve for X, plug it in, and then you're going to have to factor. Okay. So, sorry, solve for Y. Yeah. It involves substitution, and then it's also going to involve factoring. It's just kind of a lot of steps. Okay, I don't see any requests or questions. You guys are exhausted. You guys are awesome. I talked for a very long time. You are welcome. Actually, number 20 is easier than 19. But any requests, any questions? We're gonna go. Okay, I don't see any requests or questions. And I don't see anyone who wants to practice 19 or 20. You're welcome. Thank you for coming. Have a great week. See you next Tuesday. You are welcome. Thank you for joining me.